Okay, so we'll review each of the sections, probably a couple of sections at a time, starting with 3.1 from chapter 3. So to begin with, we have a relation. A relation is just a set of ordered pairs. For example, 2, -1, 5, 3, and 4, 7. Okay, so that's a relation. And then a function is a relation where for each x, there's only one y. So if you're given a set of ordered pairs like we are here, probably the easiest way to determine if the relation is a function is just look at the x values, 2, 5, and 4, and see if the same number is repeated. 2 is not repeated, 5 is not repeated, 4 is not repeated. So the relation is a function. Okay, just look at the x values. But speaking of the x values make up what's known as the domain. X could also be referred to as the input values. And then x is also the independent variable. And then y is just the opposite of that. The opposite of domain is range. That's a little bit more difficult to remember than the opposite of input. That's your output. And then your opposite of independent variable is dependent variable. And then the different ways to write a relation, you could write a relation like I have here as a set of ordered pairs. You could also write a relation as a table. So I would just make like a T table or a horizontal table. Put in all the x values and y values like this. This is my T table. So +2 and -1, 5, 3, and then lastly 4, 7. You could also make a graph, and then for some relations, not for all relations, you could write an equation. Sometimes you can't write an equation depending on where the points are. And then for a graph for functions, you could use what's known as the vertical line test. So the vertical line test says for any vertical line on the graph, if more than one point passes through any vertical line, then the relation is not a function. So if I make a vertical line here, it's supposed to be straight up and down. There's only one point on the graph that goes through that vertical line. If I move that vertical line either to the left or to the right on my graph here, there's only one point that will go through that vertical line. So this relation is a function. We also say that relation passes the vertical line test. That's the material from 3.1. So then 3.2 talks about linear functions. So with your linear functions, if you're given a table, whether it's a T table, like a vertical table, or a horizontal table like this, if a function is linear, the root word there is a line. Besides graphing the points and seeing if they're all in a line, you could see if there's a constant rate of change for both x and y. For example, say x is 2, 5, 8, and 11. There's a constant rate of change here for x. You're adding 3 every time. You don't have to add 3 as well for it to be a linear function for y, but y has to have a constant rate of change as well. For example, 0, -1, -2, and -3. Here, y is decreasing by 1 each time. There's a constant rate of change for x. There's a constant rate of change for y. So this would be a linear function. Another way that you could determine if a function is linear or not, if you're given an equation, you could write the equation in the form of y is equal to mx plus b. So what that means is if you have x and y in your equation, and then x is, say, not to some sort of exponent, or there's no square roots in there or anything, then it would be a linear function. Or I would say an easy way to tell if a function is linear or not, if it's graphed or you graph it, and the graph is a line, then it's a linear function. If the graph is something other than a line, then the graph would not be a linear function. So that's basically 3.2.